We're in section 10.1 with parametrics, and we're going to look at number 18. And it asks us to sketch the curve and indicate the direction it's going, identify the leftmost point, and then justify that we've actually found the leftmost point by using a derivative. So first, I just want to point out sketching the curve. One, you can use your calculator. So as long as you know how to use your calculator in parametric mode, you'll have an x of t and a y of t, and then you'll have a t interval. And that'll work, and you can graph it, and it'll even show you the path that it takes. But if you're asked to do this without a calculator, what I recommend is you just kind of make a table. So you can see I already have the table made here, and I went from -2 to 3 for my t values, and I just went on the integer values. And when I plug in -2 for t, I get 0 for x and 11 for y, and so on and so forth. And I think I got all these numbers right, but anyways, then you plot these points. So 0, 11, this is the first point. And then this is the second point. So the key is that this graph, it's not a function, but this graph starts here and travels through these points going this direction. And so its path is this direction. And it's because it goes down this from -2 to 3 as it goes. And so these points gradually progress that way. So this graph isn't just a graph, but it's a graph, and this object or this particle or whatever it is travels over this direction, starting here at this first point when t is -2 and traveling this way. So there's the first one, and the arrows indicate the direction. So then for part B, we want the leftmost point. And to me, it at least looks like it's this point, right? It sure looks like it's -1, 6. But then we need to justify that it is, in fact, our -1, 6, that this is our leftmost point, and which would imply that it occurs at t equals -1. And so let's see if that's the case. And it says by taking a derivative. So first of all, because we want the leftmost point, that's an extreme in the x direction. So leftmost is an extreme in the x direction. And so if we want extremes, those are extreme values. And so what we want to look at is we want to look at dx dt, and we want to set that equal to 0. So dx dt is, of course, going to be 2t plus 2. And we want to set that equal to 0. So we're going to have 2t equals -2. So t equals -1. So at t equals -1, we have a critical point. And if we make like a sign chart for, -1, and this is our t values here. And then we have like -2, and then we have 0. At -1, our dx dt is 0. If we plug in -2, our dx dt is negative. And if we plug in 0, our dx dt is positive, which would imply that this point must be a minimum. And if it's a minimum x value, right, a minimum x value is a leftmost point, because to the left is negative and to the right is positive. And so also if you note here that would imply that there is of course a vertical tangent line here, and this vertical tangent line touches the graph at exactly that point. And so for the other ones, for the other questions, it's going to be pretty straightforward as well. You're going to for the rightmost point, you're going to do dx dt, and you're going to find a maximum on the interval. And for the lowest point, if you wanted to do that, for that you would do, right, for lowest point, you would do a minimum of dy dt. And that's how you would find those, and that's how you do basic parametric graphing.